Okay, again, we're presented with 5 questions. You need to make a determination of which question looks easiest to you, which one looks the most difficult. I'm going to have to probably say number 2 looks like the most difficult question here, but I could be wrong. So I'm going to start to attack the problem, but I'm going to save 2 for last. All right? So it says over here, if it is known, I'm doing number 1 now. If it is known that the sum of 28 consecutive odd integers, well, what I want to do is I want to write down what a sum of 28 consecutive odd integers would look like to me. So I'm going to say x is odd. What's the next odd integer? It would be x plus 2. Again, the understanding is x is odd. X is odd. An odd int. All right? So, what's the next one going to be? X plus 4. They go up by 2. Plus yada, yada, yada. And how many are there going to be? There's going to be 28, right? So what's the last one going to be? Let's take a look at it. It's going to be x plus, I want to point out this is A1, this is A2, this is A3. So it looks like it's going to be, let's see, it's going to be x plus some multiple of 2. What multiple of 2? Well, 3 would give you 2 multiple of 2, so this is going to be A28. So it'd be 27 multiples of 2. All right, let me make sure I got this right. It is known that the sum of 28 consecutive odd integers is a perfect cube. We'll get there later, but I'm just summing the 28 odd integers now. Consecutive, by the way, x plus 2, x plus 4. Yeah, I think I did okay. Let's write this over here. They know it's going to be a perfect cube, by the way. What I'm going to do is I'm going to sort of erase this thing over here because I want to add this together now. And then we'll talk about what you do when you add it together. And let's take a look. How many x's would you have? Well, there's going to be 28 terms, right? So it's 28 x's. Let's write this down. Plus, what are you going to get? 2 plus 4 plus yada, 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 all the way up to 2 times 27. And again, my goal here is to add this together, right? 28x plus 1, 2 times 1 plus 2 plus 3 plus yada, 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 up to 27. And I'm going to keep doing this, right? Now, the sum of the integers 1 to 27, I know that. This is 28x. It's going to be 2 times the sum of the integers from 1 to 27. Let's see, what's that going to be? 27 times 28 over 2. Well, it's getting a little complicated, isn't it? So what do you have here? 28x plus 27 times 28. Well, I'm going to write this down. This is 28 and x plus 27. And this needs to be a perfect cube. All right, let's go through it. And I got to multiply this out, but to do that, I'm going to write the factors of it, but I want it to be perfect cube. So 28 is actually 2 times 2 times 7. And then over here, what are you going to get? You're going to get x plus 27. And that needs to be a perfect cube. So x plus 27, right, for it to be a perfect cube, right, and I'm looking for a minimum value for that, that would have to have, let's see, 2 factors of 7 in it, right? And 1 factor of a 2. Let me see if I can do that. And that's what, get a perfect cube. Let me just make sure I'm reading this correctly. It's known as sum of 28% is a perfect cube. List the first and smallest odd integers. Oh, list the first and last of the smallest. Oh, good. So I just do the minimum. That's what I'm looking for over here. And let me just take a look at that. 7 squared is 49, right? Times 2, which is 98. And x plus 27 equals 98. And then let's take a look at that. I got to take 27 from both sides, right? And x would be 71, right? Then make sure that's true. 27, 90, yeah, 98. So x is 71. So x is 71. That means that's the smallest. What's the largest? Well, the largest would be 71 plus 2 times 70, 27 is going to be 54, right? And that's going to be what? 54 and 71, 55, 125. All right, before I do that, I'm going to make sure I did that right. 7 and 5, 120, yeah, 125. So the smallest would be 71, the largest would be 125. All right, let's see how we did. And first item is 71, the last one 125. All right, that wasn't bad, all right? So I'm going to get my eraser out, and I'm going to erase this. Number one's done. I didn't think that was a terribly difficult problem. I had to go back and read it a couple times, though. And I need to know some things, like the sum of the integers, things like that. All right? Again, your approach might be different. So we got this, this. Remember, I said I was going to skip number 2 because I thought it was a difficult problem, but I could be wrong. All right? So let's talk about number 3 now. Number 3 is a triangle problem. All right? So what do they do? A triangle with integral size, perimeter of 8. So it says, oh, the area of the triangle. Well, you know what? I want to just, draw a picture of a general looking triangle over here and call this A, B, and C. And the perimeter of this is just A plus B plus C. Right? Their question is, what's the perimeter? And not what the perimeter, perimeter is 8. I'm sorry about that. Their question is, what's the area? So if I knew the sides A, B, and C were integer values, right? If I knew they were integer values, I got to be honest with you, I probably could tell you that, I hope you know the sides are not going to be equal, but let's take a look at it. Let the 3 sides, they're A, B, and C. I got that part done. I'm going to talk about the longest side, right? The longest side. Well, the longest side, if I thought about it, it's an integer value, by the way. And if you took the number 8 and divide it by 3, right? And I know it's not an integer, by the way, but it goes in 2. And how many times? 2 and 2/3 times, right? So that's if all sides were, equal. That would be, but that's not an integer, right? 2 and 2/3 is definitely not an integer. So then someone says, what would the longest side be? Well, the longest side would have to be 3 then, all right? So I'm going to say the longest side is 3. So the longest side is 3. All right? Now again, the question is, what's the area? But now I know B plus C is equal to 5. Well, let's see what makes sense, by the way. By the way, B and C have to be smaller than 4. So I couldn't choose 4 and I couldn't choose 3. Oh, no, I guess I could choose 3. And why is that? I'm assuming there's only one longest side. There might be 2 longest sides, but I can't choose 4. Right? Why is that? That would be the longest side. So what am I going to do now? I'd have to choose a number like 3. So 3 plus 2 is the only other possibility. So now I know the sides. And what are they? I'm going to say the sides is going to be 2, 3, 5. All right? So what I'm going to do now is I'm going to do the area. And let's see if I can do the area. I got a formula that I know about. And the formulas I do know about, I know really basic grade school formula. The area is 1/2 base times height. And I got to be honest with you, that looks like too much work because I'd have to figure out the height of that. All right? I guess you could do it, but I don't want to do it. So I'm going to talk about what's Hero or Heron's formula. And that's going to be semi-perimeter, S. The semi-perimeter is half the perimeter, which is 8 divided by 2, which is 4. And the formula area of a circle using Hero's formula is going to be A equals, let's write this down, It's going to be S times S minus A, S minus B, S minus C. I think I can write that down now. So the area, again, the semi-perimeter is going to be 4, and then 4 minus 2. You know what? I wrote something down crazy. I said 2, 3, 5. That is not true. B plus C is 5, but the longest side is 3, so that's not 5. It's got to cross that out and put the right answer down there. That's crazy. And that would give you 3 plus 3, but 6, 7, 8. That's the perimeter of 8. Sorry about that. But so how'd you catch that? I'm looking at this thing over here, and it wouldn't have made any sense at all. And that's going to be 4 minus 3, and then 4 minus 3. The sides are 2, 3, 3. And let's do that over here. And what do you get? A equals 4. 4 minus 2 is 2. 4 minus 1 is 1. I'm sorry, 4 minus 3 is 1, and 4 minus 3 is 1. So what do you get? Root 8. And what's root 8? 2 root 2's. All right, let's take a look at the K. This is problem number 3, I believe, right? And 3, yep. Let's see their reasoning. The 3 sides of a triangle, since the longest side must be an integer less than half the perimeter, and at least 1/3 of the perimeter. I got A is 3. I like their wording better, by the way. Now we know that B plus C is 5. The only other possible thing is 3 and 2. We did talk about that. And I used Heron's or Hero's formula. All right? Let's go back, and I'm going to get my eraser out. I'm going to erase this business over here. We're just practicing. Again, there's no need to watch these videos unless you want to. And I want to point in the blue area is probably enough information that if you worked in these problems independent of me, you'd get the same answers. So we did 1, we did 3. I'm going to do 4 now. And 4, you know, it's always a visual problem, and I'm really bad at drawing pictures. But I got to be honest with you, I got to visualize what this cube would look like. And there's 11 unit cubes in it. And if I were looking at the cube, I want to point out it would, whoops, sorry about that. I'm going to draw a better picture. It would look sort of like this to see the maximal number of cubes in the problem. And again, this is what I'm seeing over here. Now I want to point out, I'm definitely going to see this top thing here. And this is an 11 by 11. So this top part, what I'm seeing over here, if I just shade that in, I'm definitely seeing this top part. And how many cubes would I see in that? Well, I hope you realize you'd see 11 squared there. Now what I want to do is I want to say I got another section that I'm definitely going to be seeing. And that section's this section over here. And how many cubes would I be seeing there? Let me shade this in with some green color now. Well, I want to maybe write some numbers down here for you. And this is 11 by 11. That's why I said 11 squared. This number over here now is going to be 10, and this will be 11. So I'm also going to see those cubes too, right? So it's going to be 10 times 11 plus. Now I'm going to do these last cubes I'm seeing, and I'll shade them in blue. And I definitely see the cubes that are in this section over here. The question is, how many am I going to be seeing? Well, let's take a look at it. I hope you realize the height's still 10. And you know what's over here now? It's no longer, it's 10. So it's going to be 10 squared. So I'm going to see 121 plus 110 plus 100. Let's see, 121 plus 210. This is going to give me 3, 3, 1 cubes. Let's see if I did that right. Oops, gone too far. Yep, not bad. All right, let's go to the last question. I think is going to be sort of simple. Let me my eraser out. And again, I know my pictures may not be sufficiently well drawn to understand. You want to draw your own pictures. I'm going to erase this now. And I'm pretty comfortable they got, you know, what I call the low-hanging fruit at this point. I thought I really did think this too, by the way. I thought 1 was pretty simple. I thought 3 was pretty simple. I thought 4 was a nice visual problem. And I want to look at number 5 now. And, the fact that the whole numbers, I understand what whole numbers are. And I want to see if I can understand what their question is over here. So you say 4 whole numbers when added 3 at a time. Well, you know what? I'm going to write down the whole numbers for you. So the whole numbers would be x1, x2, x3, x4. So I'm going to say there are 4 whole numbers. All right, there's 4 whole numbers. All right, now what do they say? They say 4 whole numbers when added 3 at a time. So I notice this is an increasing sequence of numbers over here. So I'm going to start, if it's an increasing sequence of numbers, that, there's some ordering to these things as well. All right, so I'm just going to, make an initial statement, this over here. To get 180, though, right, I'm going to say that I'd have to add x1 to x2 to x3. And then 197 is larger, right? I'm going to say x2 plus x3 plus x4. Let's take a look. And 208 now. All right, put this one down, 208. This is where things get really kind of sticky for me. Let me put down the 222, though. x2, x3, x4. That's not making much sense to me now. I got to erase this over here. Because the next one just not going to be bigger. So I'm going to say that has to be the biggest one. So the biggest one is when I add the last 3 together. And let me go backwards on this one. So I'm going to say x4. Right, I'm just thinking now. This is always the part where thinking can get you kind of confused over here. x3. I want it to be smaller, so I'm going to say x1 now. Oh boy, I got to do this one now, right? So let's take a look at this next one. I'm going to say x4. And then I'm going to go to x2. And then I'm going to go to x1. I'm going to see if this makes any sense to me. x1, x2, x3, 180. I see an ordering to it. And let me just see if the next one makes sense. Yeah, it's not that bad. So I got to be honest with you. A lot of times you say, I'm stuck now. I don't know what to do. Well, there's four equations, 4 unknowns. I think I can do it. And what I want to do is I want to add all the equations together. And if I did that, it's some work though, isn't it? So I'm going to do 180, 197, 208, and 222. Let's see if we can add together. Let's see, 10, 17, 18, 20, 2, 4, 5, 6, 7, 8. So I'm going to say 807 if I add them all together. You may wonder, I'm doing that, I'm noticing something about this. I'm noticing I'll get 3 x1s. Let me point out what I mean by that. 3 x1s. I'm going to get 3 x2s. I'm going to get 3 x3s. And I'm going to get 3 x4s. So this would be 3 x1, 3 x2, and 3 x4. Now, by the way, these are whole numbers. And I'm starting to realize that I could probably just divide both sides by 3 quite easily. So put this down, 3. And by the way, I know 807 is divided by 3 because 8 plus 7 is 15. Let's write this down. That goes in 2, 6, 20, 6, 18, 27, I get 9. So I get 269 equals x1. Oh, by the way, I forgot to put down 3x3. Sorry about that. I just noticed that. Sorry about that. So it's x1 plus x2 plus x3 plus x4. And by the way, you may be in an infinite loop now saying, gee, that doesn't help me either. All right, but I'm starting to realize I know something. I know that they're just asking about what the largest number is, and I've already identified this one as the largest. Now the question is, do I know what x1 plus x2 plus x3 is? And I do. It's 180. Let's write this down. 269 equals 180 plus x4. And what's that going to give you? Let's see. 89, right? So the largest number would be 89. All right? Are they asking for the other numbers? No. So I'm done with that. Let's check our key, though. And then we get to that last question. Whoops, wrong. I got too far there. Yeah, 89. Okay? Let's do that last question. And I want to point out, I know it's tough. I'm going to start to erase things over here. And remember this, that when you're doing a competitive exam, that you probably can't answer every question on it. Otherwise, the exam would be too easy for everyone if everyone's answering every question on it. So you'd hope that some kind of differentiation between participants. Some people will be better than others. But what have we done so far? 1, we've done 3, we've done 4, we've done 5. Now, in hindsight, I would probably say the easiest one for me, although I'm kind of not very visually good at this, I'd say 4 was pretty easy to do. 1 wasn't so bad, 3 wasn't so bad, and really 5 was tough, but it really wasn't as bad as I thought it was going to be. I got a 2. I got to be honest with 2, though. For some students, they have an advantage over other students. They've seen more material. All right. Now, certainly, when you're seeing more material, things become easier for you. But the greatest integer function, by the way, there's a footnote over here too. Certainly, if you're studying computer languages, your teachers may use different notation, by the way. And some of the notation they might use is this one over here. Now, if you're studying a computer programming language, they use what's called the floor function. All right? But that's something you're familiar with. That's fine. If not, don't worry about it. So, I could read that to you. But the problem with reading these things, it's kind of really hard to understand, but it says the greatest integer not larger than x. So, I got a visual understanding of this. And I want to point out what I mean by a visual understanding of this function over here. And the function I'm talking about is this function. So my visual understanding of this over here, just visually, kind of visualizing it. Let me just change the color over here. And I'm going to say it looks sort of like this over here. It's also called a step function. Sort of looks like this over here. And sort of looks, you get the idea. But, I got to think what happens on the other side of it. Well, it's going to look sort of like this, of a step function, right? I think you get the idea. Again, that takes time to digest, by the way. All right, so what I got to do is I realize that these things are defined on intervals. So then the question is, what does this function look like defined on intervals? And that's where I got to write this down now. So f of x is going to be equal to something. And there's going to be a bunch of integer intervals between -2 and 2. So I'm going to write the intervals down for you. The first interval would be starting at -2 and going up to -1, but it's going to jump there. And then it's going to start up at -1, and it's going to go up to 0, and it's going to jump there. It's always going to be jumping at the integers. And then it's going to start with, 0. Right, I'll put this one down for you. I'm going to write this over here. It's going to start at 0 and then go to 1. It's going to jump at 1. I'll put this down. 1. and then it's going to get to 2, and then it's going to jump to just the number 2. All right? And this is going to be x's on this. X is here, x is here, x is here, x is here, x is here. I got to write this down now, don't I? Now what's going to be x minus, well, the integer function is going to be an integer. I just don't know what the integer is yet. I have to look at my graph. Again, I don't know what the integer is. I have to look at my graph. All right? And I gotta wonder what that's going to look like, right? So between minus, you know what? Let's go between 0 and 1 first. That's a pretty easy one. And what's that going to look like? That's right over here. And that's just going to look like 0. And let's go between 1 and 2. That's just going to look like the number 1. And let's go the next jump right over here, and that's just going to look like the number 2. Well, I think I get an idea over here. Over here, it's going to be minus 1. That's between minus 1 and 0. So let's say plus 1. And then this over here is going to be minus 2, and minus 2 is plus 2. All right, so here comes my next big problem. I got the thing written down, but now I got to graph it. Well, what I know about every single object, it's a parabola. And I'm not going to say I'm doing a great job of graphing it, but I got my function written down, and let me put my axes down. And I do know I got pictures here, and I got to be really careful with my pictures. You know, I'm going to minus 2, and then minus 1. I got the 0, I got the 1, and I got the 2. And I have to start thinking about what these things are going to look like. And I got to be really, really careful, right? Really, really careful. So the one thing I noticed about these, they're all parabolas. And probably the easiest one to do is probably this one right here. And that's going to be a parabola that starts at 0. That's right here. Its vertex is going to be there, by the way. But it just goes from 0 up to 1. And what would it be at 1? It would be like up here. So I'm going to say it looks sort of like this, but it doesn't touch that. All right, that one's done. Now I want to do this one over here. And that starts here. I can touch the 1. And then it's a parabola, and the vertex would be there, so it goes up like this. This one's done. Now let's do this one over here, and it just says x is 2, so it's just going to be a single point here. All right? Now I'm getting a feel for it, and what's this one going to be? Another parabola that has a vertex here, but just between minus 1 and 0, and it's going to look like this now. But it's going to have an open circle here. Likewise, at minus 2, it'll be 0 here, and it'll look like this over here. All right? If you want to know what these points are over here, this point's going to be 2, 1. It's open. This point's going to be 1, 1. This point's going to be 0, 1. And this point's going to be minus 1, 1. All right? So that's my graph. Let's take a look. And what I want to do is I want to look at what they put down. And what number is that? This over here. And let me just take a look what they got written down. I see one small typo here. Let me see if I see a typo. No, I don't. Let me see the graph. I like the graph better. By the way, their scale's a little bit odd, though. You notice that this one up here is much larger than the one down there? That happens, right? They're a different scale. Not a bad-looking picture. I like their picture better, by the way. Anyway, here's the deal. This was not a bad problem set, all right? I'll be honest with you, though, do not feel discouraged if you're looking at these things saying, I couldn't get this problem or that problem. Be encouraged when you can find one problem that you can do. Always be encouraged by that. All right, now if you're looking and you can't do any of the problems, it might be time to go back and, look at other types of problems and then just try to work your way forward. You could also go to YouTube. YouTube's an excellent place for watching people solve problems. And some people are good at it, some people are not good at it, but that kind of varies from student to student, by the way. But here's the deal. Look over the problem set, all right? And let me make sure I did this okay. Yeah. So what I was saying is, if you need to reach out to me, my email address is Bannon. And that's B as in boy, the @ symbol, NNON.US. And again, if you email me and I'm not being overwhelmed with requests, I'll get back to you. If you have a comment or want to express a concern, please feel free to do so. And what I mean by that, I do entertain people writing me, and I write back, especially if they're, something to say that's productive. I write back. You may wonder why YouTube the comments are turned off. I think that's a default setting on YouTube when things are designed for children. All right, so this is age appropriate for anybody that knows this subject. Whether it's someone in middle school, high school, college, someone out of school, it really doesn't matter. Whatever level you're at, that's fine. But again, if you need to reach out to me, please do so by email, and I'll try to get back to you if I can. Thank you.